Hello, Maniba. Good evening.
Good evening, ma'am.
How are you? Why you have not joined the last session?
Ma'am, I have back-to-back exams going on, so I couldn't.
Okay, okay. So, sorry if I sound a little raspy. I think I'm getting a cold. Okay, so just excuse my hoarseness.
It's all
So
right.
in the previous lecture, we have we just did this, the reaction with the ammonia and its derivative. Okay, the nucleophilic addition we have started. तो जब तक वो लोग बच्चे और स्टूडेंट्स नहीं आते हैं, let's do that. Okay, let's summarize these the nucleophilic substitution reaction. Okay, so what is nucleophilic substitution reaction? So when the nucleophile, suppose this is your carbonyl compound, when you add a nucleophile, okay, so this is a nucleophile. So between this carbon and oxygen, this carbon is partial positive and this oxygen is partially negative because it is more electronegative, right? So this nucleophile, when it comes, it will attack this positive center, this carbon. Okay, so when it attack this carbon, so this bond will shift over here, right? So this will give you O minus, and here the nucleophile will get attached. Now, further, when you add H plus ion, okay, acidic medium में, when you treat it with, so you will get alcohol over here, okay, and here the nucleophile. So this will give you a additional product. Okay, the nucleophile will get attached to this carbon and the OH group will attach to the same carbon. So you have to keep in your mind this OH and the nucleophile, both the groups should be attached to the same carbon. So it will give you a geminal type of compound. So what is geminal compound? When both the groups should be attached to one carbon, same carbon. So this is a geminal type. Okay, now let's see the addition of ammonia, how the ammonia will add up, okay, to the carbonyl compounds. So this is the NH3 ammonia. So what we are supposed to do, can we write ammonia like NH2? Just a second. Okay, so yeah. So what you're supposed to do, this oxygen, this bond you will break, pi bond will be break, right? So this oxygen and a two hydrogen. This ammonia has three hydrogen, right? So two hydrogen from this ammonia, okay, and one oxygen from the carbonyl compound will give you a water. So dehydration will occur, right? Dehydration will occur, and you are supposed to form the imine. So what is imine? So imine is carbon and double bond nitrogen. What you are supposed to do? Just oxygen and two hydrogen from this ammonia will get attached, and it will dehydration will occur, right? And you have to attach nitrogen by a double bond. Carbon double bond nitrogen आपने form कर लिया. What is this? This is your amine and one hydrogen from that carbon, nitrogen, and one hydrogen. So it will form amine. Amine. So if I write this ammonia as NH, okay, what is this? This is again ammonia, NH3. Three hydrogen is attached to the nitrogen, right? So what you're supposed to do, this one, H2 plus oxygen. Okay, आपने remove करा दिया as a water, plus this carbon and this NH bond. This NH bond will get attached to carbon by a double bond, by a double bond. So basically, you have to prepare the imine, carbon double bond nitrogen. This is your imine. Clear, Muniba?
Yes, ma'am.
Okay. So here, suppose if I replace ammonia है ये, okay, and we are just doing the reaction with ammonia and its derivatives. Okay, so if I replace this hydrogen by any group, suppose we just get मैं इसे Z लिख दूँ. So Z can be anything, hydrogen, OH group, any group can be Z. So if I attach NH2, this hydrogen replace कर दिया मैंने by a Z groups. So what you are supposed to do, again the same mechanism. NH2, NH2 should be there, right? NH2 will be fixed in each and every reagent. Okay, the reagent may NH2 will be same. Okay, this is fixed. What will change? This Z group. This Z group will be changed. If you attach the Z group के जगह पे आपने attach कर दिया OH, okay, so it will become NH2OH, right? And NH2OH is a hydroxylamine. What is this? This is your hydroxylamine. Okay, if I replace this Z group के जगह पे मैं if I Z group is equals to NH2 group. Okay, NH2, this one is fixed in each and every compound. In each and every derivative, this NH2 group will be fixed. Only this group, Z group जो है, इसके जगह पे मैं attach कर रही हूँ, this OH group, this NH2 group. So if I attach NH2 group, okay, Z is equals to NH2 group. So what is this? NH2, it is hydrazine. It is hydrazine. Okay, and you should know the name of these compounds. What is this? NH2 is hydrazine, right? So suppose we have this NH2 and Z. So again, the same mechanism we will follow. Two hydrogen from here and this oxygen from this carbonyl compound. Okay, water will be liberated out, and what you get? First, you have to, okay, आपने imine बना लिया, carbon double bond nitrogen. Okay, and after that, when you form imine, you have to place Z group over here. Just attach the Z group to the nitrogen. That is the basic representation. Then general reaction. Z group can be anything. NH2 is fixed. First, just remember what you're supposed to do. Just remove the water, okay? H2 from this NH2 and oxygen from the carbonyl compound. It will liberate as a water, okay? Then in the product side, you have to prepare the imine. What is imine? Carbon double bond nitrogen. आपने ये बना दिया. And after that, you have to attach to the nitrogen which group? This Z group. Okay, other than what is Z group? Z group, the group other than NH2 group. Other than NH2 group. आपने NH2 first, you have to see the NH2, whether the NH2 group is present or not. If the NH2 group is present, then other group, okay, other fragment then the other than the NH2 group is known as your Z group. Okay, suppose we have this one, this reaction. Okay, what you're supposed to do? Two hydrogen from here and one oxygen from here. It will liberate as a water. Okay, dehydration will occur and water will be released. Now, you will prepare the product. Product में first step will be carbon double bond nitrogen. Okay, carbon and double bond nitrogen. Imine आपने बना लिया. Then what is Z group over here? You have to analyze what is Z group in this one. Okay, so Z group here is the other than NH2 group. Okay, this is NH2OH, hydroxylamine. In hydroxylamine, what is Z group? So Z group is the other than NH2 group. This NH2 group को आपने omit कर देना, and this OH group, other than NH2 group, which group is present? OH group. So just attach this OH group over. Okay. And what is the name of this one? So this is known as hydra. Okay, NOH. So this is known as oxime. Okay, carbon double bond nitrogen. And when on to the nitrogen, when OH group, hydroxyl group is attached to the CN, it is known as oxime. Is it clear, Muniba?
Yes, ma'am.
Okay, do the next two. This is hydrazine, NH2 is hydrazine. Okay, and what is this? NH2, NH, and your benzene ring. Yes, Jovita will tell me. What is this, Jovita? What is the name of this structure? NH2, NH, and then phenyl ring. What is the name of this structure? We have already discussed in the previous class.
COONH2 plus H.
What is the name of this one? What is the name of this? Yeah. Just like this, NH2 is hydrazine. So what is this? NH2, NH, and phenyl ring. What is this?
Dihydrogen benzyl.
डाइहाइड्रोजन. यहाँ पे आपको डाइहाइड्रोजन कैसे दिख रहा है? You were there in the previous class. What is this? NH2, NH2. See, this is a hydrazine. Okay, What is this? This is NH2, NH2. This is hydrazine. And if you are replacing one hydrogen from the hydrazine is replaced by a phenyl group. So what is this? This is your phenyl hydrazine, right? So what is this? This is your phenyl hydrazine. That's why I told you, just revise your notes. After the class, just revise your notes. Yes, Moneva. Yes, sir. Tell me the hydrazine reaction. What will be the product in this case?
C double bond N NH2
Very good.
plus H2.
Yes. And this is known as hydrazine से किसमें convert हो रहा है? This is hydrazone. Hydrazone. Okay, so you have to remember the name of the structure too. So when the carbonyl compound, okay, is treated with hydrazine, so which product you will get? So you will get hydrazone. Okay, and question can be like this: how you will convert the hydrazine to the hydrazone? Okay, so how you will convert when you treat it with the carbonyl compound? CO group should be there. Okay, it could be your aldehyde or ketone. If you attach CH3 over here, and if I attach hydrogen over here, so what is this? This is the aldehyde. And to the both sides, if I attach alkyl group, so it is your ketone, right? Okay, what about the next one, Muniba? Just try it.
C double bond N
Yes,
NH with the benzene ring.
yes, very good. Okay, so I'm just writing the phenyl. Okay, so this is known as your phenyl hydrazone plus water. Okay, now let's understand the mechanism how we get this product. So suppose this is your carbonyl compound plus NH3. Okay, so the nitrogen has a lone pair of electron. Okay, so the lone pair is negatively charged, you know very well. And between this carbon and oxygen, the question is this nitrogen will attack which group, which atom, carbon or oxygen? Yes, Maniba. कार्बन पे अटैक करेगा या ऑक्सीजन पे? दिस नाइट्रोजन, द लोन पेयर ऑफ द नाइट्रोजन.
Oxygen.
Why oxygen? Why oxygen? You have to check which one is electropositive because this nitrogen has a lone pair and lone pair is negative. If it attached the oxygen, ये अगर oxygen पे कोशिश करेगा attract करने की, so there will be a repulsion because oxygen between the carbon and oxygen is more electronegative. Right? So you have to check between these two groups, which one is electropositive. So between this carbon and oxygen is more electronegative, so it will acquire partial negative charge, and this carbon will acquire partial positive charge. Okay, Muniba? And because this nitrogen has a lone pair, so lone pair is nothing, it's a non-bonded electron, negatively charged, and negative charge किसको attract करता है? Positive one, right? So this nitrogen, the lone pair of the nitrogen, will attract this carbon. Why she has got disconnected? Hello, Maniba.
Yes, ma'am.
Okay, now see. So we are just doing the mechanism. So this nitrogen will not attract the oxygen. It will attack the carbon because between this carbon and oxygen is more electronegative. right? So it will acquire partial negative charge, and this carbon will acquire partial positive charge. Okay, so the nitrogen, the lone pair of the nitrogen will attack this carbon, so this bond will shift over here. So what happens? Carbon is a negative charge, and it will get NH3, 3 hydrogen. Okay, now let's understand the mechanism. Now see, between hydrogen and nitrogen, yeah, here the nitrogen will get positive charge. Why? Because nitrogen की valency क्या होती है 3. But now it has 4 bonds. 1, 2, 3, 4 bonds. So it will acquire positive charge. यहाँ पे positive charge होगा nitrogen के पास. Now, so this oxygen, between this hydrogen, let's check the polarity, right? Which one will get positive, partial positive charge, and which one will partial negative charge. So this between this hydrogen and nitrogen, which one is more electronegative? Which one is more electronegative? Just let me know. Jubita, between the hydrogen and nitrogen, which one is more electronegative?
Nitrogen.
Yes, nitrogen. So nitrogen will get negative charge, and this hydrogen will get positive charge. Partial positive charge will be on the hydrogen. Same for that. Same for this bond. Okay. Now this oxygen has a negative charge, so it will try to abstract this hydrogen. It will try to abstract this hydrogen. ये abstraction, proton का abstraction हो रहा है, right? This oxygen का protonation हो रहा है, and this bond will shift here. Okay, just cancel this positive charge. Okay, so next step. So here OH, okay, the hydrogen, the oxygen will abstract this hydrogen. Now nitrogen. Now nitrogen has 2 hydrogen, right? Again, the same thing will happen. This oxygen, which is having a lone pairs. Again, it has a lone pair. So what happens? This will abstract this hydrogen, right? And again, this bond will shift over here. Okay, so basically, what happens? So when it abstracts this hydrogen, so what happens? So here OH2 plus. यहाँ पे क्या हो जाएगा? OH2 plus, and from here the water will be liberate out instantly. So ये बहुत ही instant reaction होता है. This OH, see here, this OH is already there, and when this oxygen abstracts this hydrogen, so what happens? It will become OH2 plus. Okay, and because it is very unstable, so here from here this bond will break and the dehydration will occur. The water will be released. Right, so I'm not writing that step. Okay, so here water will be liberate out, and this bond is shifting over here, so it will form the imine. Okay, so carbon, double bond nitrogen, and here one hydrogen, right? So it is forming carbon, double bond nitrogen, and one hydrogen. Okay, and plus what? Plus what? Is it clear? The whole mechanism is clear or not?
Yes, ma'am.
Yes, ma'am.
So basic thing, this is the main reaction. The mechanism will be same. What you are supposed to do, 2 hydrogen from this nitrogen and 1 oxygen from this carbonyl compound. Okay, they will liberate as a water. Water will be removed, and you have to make the imine. First, आप carbon and nitrogen bond बनाओगे and attach the Z group. So general, I'm just writing the general formula for the product. Okay, in all the cases, product will be this. Product will be this. Only the Z, okay, this Z group will vary. Only this Z group will vary. When you treat the carbonyl compound with the ammonia or its derivative, so you will get this imine, okay, which is attached to the Z group. Okay, so Z group will be vary in each and every derivatives. और आपको Z group analyze करने आना चाहिए. That is important. Okay, now. Now see here. So NH3, I have already discussed that NH3. So you can write NH2 and H. So other than NH2, which group is present? Only hydrogen is present. So what is Z over here? So Z is hydrogen. Z group is hydrogen, right? So what you are supposed to do? Product क्या हो जाएगा? You will form the carbon double bond nitrogen imine, okay, and just attach the Z group. And Z group क्या है? Hydrogen. Okay, similar for the NH2OH. For the NH2OH, this is the reagent. Okay, and in each and every reaction, We are just treating it with carbonyl compounds. This is a reactant. What is reactant? Reactant is this. Reactant is same. Okay, just the reagent is changing. Okay, the reagent change हो रहा है and accordingly the product will change. Only the Z group in the product will change. This will be same. C and double bond nitrogen will be fixed. Is it clear?
Yes, ma'am.
Okay, so see here. So this is NH2OH, hydroxylamine. Hydroxylamine. You should know the name of this structure. This is OH group, hydroxyl, and amine. So what is other than NH2? Which group is extra? OH group. So what is Z? Z is OH. So you will first prepare, just draw the carbon double bond nitrogen and just attach the Z group. What is Z group? OH. So that is your oxide. Oxide will be formed. Similarly for the hydrazine, phenyl hydrazine, and so on. Just see that. So the hydrazine we have already discussed. Yeah, phenyl hydrazine के बारे में भी हमने discuss किया. Now see this structure. Fifth one. Say the fifth one. What is this? 2,4. What is the name of this structure? You should know first. It is 2,4. This is hydrazine. The hydrogen in the hydrazine, NH2 is a hydrazine. When you replace one hydrogen by this group, what is this group? This is 2,4. Okay, 2, 1, 2. This is first, 2, 3, and 4. On the first, second, and fourth position of this benzene ring, the nitro group is attached. So what is the name of this structure? 2,4-DNP. What is this? 2,4-DNP, dinitrophenyl. Okay, and what is this? This is your hydrazine. So the whole structure name is 2,4-dinitrophenyl hydrazine. Now, what is Z over here? So as I told you, other than NH2 group, this is NH2 group. NH2 group को आप omit कर दोगे, and this group, this is your Z. Okay, so how you will write down the products? First, write down carbon double bond nitrogen and attach Z group, all the Z groups. So what is Z in this? NH, this whole thing. Okay, this whole thing you will attach. So you will write NH and this your phenyl ring. And on the second and fourth position, you will attach the nitro group. Yeah, so you will get 2,4-dinitrophenyl hydrazone. Okay, when you treat a carbonyl compound, it will give you a 2,4-dinitrophenyl hydrazone. And you know the mechanism. आपको mechanism पता है? So you can also try to write down the mechanism for each and every structure. Okay, what you're supposed to do? Just follow this. Just follow this one. Instead of NH3, you will write down the derivatives of ammonia. Okay, and just follow the same trick. Some same mechanism will be there, and it will be more clear when you write by your own self. Now, this one, sixth structure, देखो. What is this? NH2, NHCO, NH2. This is your semi-carbazide. This structure is known as semi-carbazide. इससे बहुत questions आते हैं. Questions कैसे पूछेंगे? Why this nitrogen is delocalized? Right? Why this nitrogen does not attach to the carbonyl compound? Okay, why only the terminal nitrogen can attach? Okay, so this type of question we will discuss. Okay, why? What is the reason behind that? So first, you should know what a semi-carbazide. Semi-carbazide is NH2, NHCO, NH2, right? And what is Z group over here? So Z is other than NH2. What is this? NHCO, NH2. That is the Z. So semi-carbazide is converted to a semi-carbazone when it is treated with the carbonyl compound. Okay, you can see the structure carbon double bond nitrogen, and you have attached the Z group. Z group क्या है? NHCO, NH2. That is the Z group over here. Similarly for the amine. Okay, so in the NH2 other than NH2, which group is present? Only R group, alkyl. Okay, so this is Z. Okay, and you will attach the after carbon double bond nitrogen, you will attach R. So it will give you a substituted imine. And it is also known as Schiff's base. What we call this a structure? This is Schiff's base. When the amine is this, when the imine, not amine, when the imine is this, and here there is a substitution like alkyl group is present to that nitrogen. Right? So this is a Schiff's base. This is known as Schiff's base. Is it clear?
Yes, ma'am.
Okay. I will not give you extra time to note it down. Okay, I will share the notes because I have to complete this chapter anyhow before 27. Okay, if it is okay, Muniba, for you, that we can schedule some extra classes before 27
Ma'am, actually, I have bio exam also on Sunday.
on Sunday. Okay, then you can inform us if because half chapters we have finished till now. Okay, there are more topics like aldol condensation, your cross aldol condensation. The main reactions are left, right? So we need 1 to 2 more classes for that. Okay, so please inform the team whenever you want the extra class. Okay, Muniba.
Yes, ma'am.
Okay. Okay, so suppose the remarks, you can write down the remarks. Suppose we have 2,4-DNP. Okay, 2,4-DNP dinitro. This is structure. On the this here there is some group, and on the second position and on the fourth position nitro group is attached. So this is known as 2,4-DNP dinitrophenol, right? Suppose this is OH and this is your NO2 second position pe, and this is what is this 2,4-DNP dinitrophenol. Okay, so on reaction with aldehyde or ketones, it gives a yellow or orange or red PPT. Okay, so when you react aldehydes or ketone with this structure, 2,4-dinitrophenyl, and you can also use 2,4-dinitrophenylhydrazine. Instead of this OH structure, you can attach the hydrazine also. So it will give you a red or reddish, orangish, or yellowish PPT. Okay, so it confirms that the aldehyde and ketone is present in the sample. Suppose we have a known sample, A sample, DIAMA, okay, and we don't know whether it's aldehyde or ketone. Okay, so this test is basically is to distinguish the aldehyde and ketones with the other groups like alcohol, ester, carboxylic acid, etc. So suppose we have a sample. When you add 2,4-dinitrophenol, so what happens? It will give you a yellow, orange, or red color pigment. Any of the color, किसी भी color का आपको मिल सकता है. It depends. So when you got the yellow, orangish, or reddish color PPT, so it confirms that this A sample, it can be either aldehyde or ketones. Means this is carbonyl compound. So this test is for the distinction between the carbonyl compounds from the other compounds, alcohol, your carboxylic acid, etc. Okay. Now this question is important. This question can come in your statement type of question. Okay, reason type of question. So there are two NH2 groups in semi-carbazide. So they don't give you the structure. Okay, they just give you the name, what is same. So you should know what is semi-carbazide. If you don't know what is semi-carbazide, then how you will explain? Okay, so semi-carbazide is NH2, NH, NH2. Okay, the question is there are two NH2 group in a semi-carbazide. However, only one is involved in the formation of semi-carbazone. Why? What is the reason behind that? So see, you can see this one. This NH2, the right side, this is carbonyl compound. The right side, this NH2. So this is involved, the lone pair of this nitrogen is involved in the resonance with this carbonyl compound. Okay, so it is not free. The lone pair of the nitrogen is not free. It is it is involved in the resonance with the carbonyl compound, right? So due to the delocalization of lone pair and the resonance, it will not involved in the reaction. Okay, it will not react. It will not act as a nucleophile, right? So ये इसका न्यूक्लियोफिली बहुत ही लेस न्यूक्लियोफिलिसिटी होती है इसकी दिस नाइट्रोजन की व्हाई due to the involvement in the resonance, okay, due to the delocalization. But what about this one? This NH2, this terminal NH2, right? This nitrogen is not involved in the resonance, right? This is free. इसके lone pairs क्या होते हैं? Free होते हैं. So this NH2 has a localized lone pair, so it can attack. It is more nucleophilic. It is more nucleophilic. Right? So इसके electrons क्या करते हैं? This nitrogen can act as a nucleophile and it can attack the carbonyl compound. If you treat it with carbonyl compound, okay, CO group. So this lone pair, not this one. So this lone pair, this nitrogen lone pair, the terminal one, this terminal one. So it will attack this carbonyl compound and it will convert the semi-carbazide to a semi-carbazone, right? So iske hydrogen, this two hydrogen plus oxygen will be removed as a water and you will add carbon double bond nitrogen. Okay, carbon double bond nitrogen and this whole thing is a Z group, NHCO, NH2. So it will convert the semi-carbazide to a semi-carbazole. Okay, so the reason is that this is involved in the resonance with this carbonyl compound, but this is free. Okay, Maniva?
Yes, ma'am.
Okay. Jibata, is it clear?
Yes, ma'am.
Okay. We are just revising the topic. Okay, so these are some questions which we have discussed in the previous class. Draw the structure of the following. Question क्या है? Semi-carbazone of acetone. How you will draw the semi-carbazone of acetone? Okay, so let's see if this type of question come in your exam. So how you will write? So acetone का आपने क्या draw करना है? Semi-carbazone. Okay, so we just take the acetone CH3CO CH3. This is acetone plus semi. When you add this acetone to a semi-carbazide, okay, then this will react to form a semi-carbazone, right? So CH3CO CH3, and what is semi-carbazide? NH2 NHCO NH2. You know very well, okay, and you know very well this nitrogen will not react with the carbonyl compound. This nitrogen lone pair will not attack, right? So this nitrogen lone pair will attack, and so from here, this two hydrogen and one oxygen will be liberated as a water. Okay, okay, and how you will form? First step is same, carbon and double bond nitrogen आपने prepare करना है, right? Carbon double bond nitrogen. Then here you can see CH3, CH3. This is what is this? This oxygen. Oxygen will be removed and this carbon double bond and आपको nitrogen बना this carbon के साथ, right? And these two carbon are free, so you will write CH3 and CH3. Now, what is the Z group in this? Z group is this one, right? This is Z group. So you will write NH, NHCO, and NH2. Yeah, this one plus your what? So this will be your semi-carbazide. This is structure. This is the semi-carbazone of acetone. Is it clear?
Yes, ma'am.
Next, draw it by yourself. Semi-carbazone of cyclohexanone. Mechanism will be same. If you understood the mechanism, you can do any of the question. Just quickly do that. Hello, Aisha. How are you?
I'm fine, ma'am.
Why you have joined so late?
Ma'am, actually, I was not well, so I did not see the class timings today.
Okay. Okay, so we were just revising the topic because Moniba was not there in the previous class and she has her exam on 27th, right? So we have not started a new topic today. Now I will start, okay? Yeah.
Done, ma'am.
Yes, Moniba, tell me the whole reaction.
Um, Cyclohexane with a C double bond O
Okay, do one thing. Just tell me the semi-carbazone of cyclohexane. Just the product only.
Okay, cyclohexane with C,
Mhm.
double bond N, NH, C double bond O, NH2.
That's very good. So that is structure represent the semi-carbazone of cyclohexane. Right. So I have given this in your homework. Reaction of following with ammonia and all the ammonia derivatives. So formaldehyde, acetone and cyclohexane. So these three कि आपको सबके साथ reaction show करनी थी, right? With ammonia and all the derivatives of ammonia which we have discussed here. All the 7 reagents के साथ you have to discuss. Okay, you have to write down the reaction with NH3, with NH2OH, with NH2NH2. Okay, this all 7 reagents के साथ you have to show the reaction of these three: formaldehyde, acetone, and cyclohexane. Okay, so to just quickly write down your homework, Moniba. I've already given the homework to Aisha and Jupiter. And Aisha, I have checked your homework. Very good, bache. You understood this topic. Why you have not submitted your homework, Jupiter?
I had exam, ma'am.
When? When is your exam?
No, ma'am, I had class test.
Okay. So it will take only like 15 to 10 minutes. Right? So just 15 to 10 minutes lagega. So just do that question. Just
Yeah, ma'am, I will submit.
yeah.
Sure, ma'am.
Okay. So next topic we have discussed the addition of HCN. Okay, just quickly do that. How the addition of HCN. So when you add the carbonyl compounds to HCN, right? So we are just doing the nucleophilic addition reaction. Nucleophilic addition reaction में ही हम पढ़ रहे हैं. These are the subtopics, right? So when you add the carbonyl compounds, when you treat the carbonyl compound with HCN, okay, so it will form cyanohydrin. It will form cyanohydrin. So this HCN, okay, in the aqueous medium, okay, in the aqueous medium, so it will give you CN minus plus H2O, not in the basic medium OH minus, right? So when you treat it with OH minus, so it will give you water. So it will dissociate from H plus and CN minus, right? And this H plus, it will get combined with this OH minus and it will liberate as a water. Okay, so water will be released. OH and one hydrogen. So two hydrogen plus one oxygen. So H2O will be released. And this is Cn minus. And this Cn minus is a nucleophile here. Okay, so when you take the carbonyl compound and the Cn minus is the nucleophile. So this nucleophile will attack this carbon center. This bond will shift here. So it will give you O minus and Cn and this one structure. Then further acidification करोगे आप, so it will give you OH. The hydrogen will get attached to this oxygen and it will give you a this structure. So what is this structure? This is your cyanohydrin. Cyanohydrin. Again, the same mechanism you will follow. The OH and Cn should be attached to the same carbon, right? Same carbon पे आपने क्या attach करना है? The cyanide group and the OH hydroxyl group. Okay, just keep this in your mind. For example, this question. Well, this was the first. This is the second. CH3CH. Okay, you just take the ethanol aldehyde. So what you're supposed to do? I'm just, you know the mechanism, whole mechanism, you know. But if in your exam they don't ask you to write down the mechanism, so don't waste your time to write down the whole mechanism. But because it will take time. So I will give you a trick. What you're supposed to do. This carbon, see this carbon. Just write down this carbon. Okay. Now this carbon is how many groups? CH3 group is के पास. So just write down the CH3 group, and it has one hydrogen. Okay, one hydrogen. Okay, so just a second, let me draw like this. So it has one CH3 and one hydrogen. Now what you're supposed to do, this oxygen, this carbon, first it should have a carbonyl compound, right? So this carbonyl will get oxidized, will get reduced basically. So this carbonyl ketone जो होगा carbonyl group will get transformed into a OH group. यहाँ पे आपने क्या करना है OH, and on the same carbon to the same carbon just attach the CN. That is supposed to do in this type of question when you have to write down the product only, because you know very well the mechanism. This first step में क्या होता है, cyanide will get attached to this carbon, and this bond will shift over here. There will be a negative charge. When you do the acidic hydration, so what happens? H plus ion will get attached to this, and you will get a cyanoid. Okay. Similarly, say this is ketone. What you're supposed to do? Carbon CH3 as it is, CH3 as it is, right? Now this ketonic carbon, right? This oxygen will get transformed into a OH, and to the same carbon you have to attach the CN. That is very easy. Similarly, this one, this is the carbon and oxygen. Cyclohexane. This oxygen will get converted into a OH group. Okay, and to the same carbon, you will attach the CN group. So that is your cyanohydride. Is it clear?
Yes, ma'am.
Okay, now just quickly let's do the next one. Addition of hydrogen sulfide. Addition of hydrogen sulfide. So hydrogen sulfide or bisulfide is your HSO4. Okay, so we can use hydrogen sulfide, potassium hydrogen sulfide. Okay, so this HSO group, SO3 group is your hydrogen sulfide, or we can also call it as a bisulfide. So when sodium hydrogen sulfide or sodium bisulfide is treated with the carbonyl compounds, so it will form basically, आपको see this, what you're supposed to do, carbon, this bond as it is, you will write, okay, and this group, this carbonyl group, this oxygen, आपने क्या लिखना है, O minus. So O minus, this will sodium plus and SO3H minus. This will get dissociated from Na plus and HSO3 minus. So this sodium will get attached to this oxygen first. What you're supposed to do, just write on the carbon. Then this carbon का double bond आपने break कर देना, right? So when you just remove this double bond, you will get O minus and Na plus. Now to the same carbon, just attach this SO3H group, the rest of the group, SO3H group. Okay, first. Okay, so you will get this first. Now, what happens here? Here, due to the more stability, this is not quite stable. This is not stable. What happens from here? This hydrogen, this proton gets transferred here, right? This hydrogen gets transferred here. So basically, this process is known as proton transfer. Okay, proton क्या हो रहा है? Transfer हो रहा है from this SO3 to oxygen to become more stable, to become a bisulfite addition product. So when it transform over here, so OH, you will get OH finally, and here you will get SO3 and A. SO3 and charge क्या होगा? Na will get positive charge and SO3 will get negative charge. So that is your final product. Bisulfite. Bisulfite addition product. You will get this finally. This is the proper mechanism. Clear?
Yes, ma'am.
Okay, now see this. CH3CHO. When you have to write down the product only. So you will not follow the proper mechanism. Product आपने लिखना है. So what you're supposed to do, CH3CHO, right? So you will write carbon, this carbon, right? This carbon. Next, okay. Let's do one more thing. Like when you treat it with formaldehyde. So simple से start करते हैं. When you treat the formaldehyde with NaHSO3, so what happens? This carbon, okay, this aldehydic carbon you will write. Okay, then this carbon has two hydrogen, one hydrogen, and this oxygen bond. Okay, so double bond. Can we write this HCHO? This is the formaldehyde. We can write like this also. So this bond, this carbon, this pi bond will break and you will get O minus. Okay, O minus, and here you will get, first here the Na will get attached, but आपको final product लिखना है. So what you are supposed to do to this oxygen, just attach the hydrogen, right? And this Na and SO3 just attach it here, SO3 and so it will give you a bisulfite addition, right? Now similarly here, this carbon has one CH3 group and one hydrogen group. Okay, so this oxygen के साथ आपने क्या attach करना, hydroxyl group. Now the remaining part, the sodium and HSO4. So not HSO4, the sodium and SO3. So SO3 and N will get attached over here and you will get this. Okay, similar case, you will follow the same thing. Okay, just draw this carbon, here one methyl group, other methyl group. Okay, and this is a ketonic group. It will get reduced to a OH. Okay, ketone group से आप क्या convert कर दोगे, OH. Now here to the same carbon you will attach the remaining SO3 Na. Similarly, this one, cyclic structure, and to this you will attach OH, and to the same carbon you have to attach SO3 Na. Okay, is this topic clear?
Yes, ma'am.
Okay. Now, this was these topics we have discussed in the previous class. Now I'm going to start a new one. Fourth reaction. This is again a nucleophilic addition. Reaction with, and I think we have discussed this. Reaction with Grignard reagent. Grignard reagent. Okay, see this reaction. So suppose we have this carbonyl compound. Okay, in the first step, first I'm just discussing the reaction only. So suppose we have RMgX. This is your Grignard reagent. Second, followed by the hydration. So you will get carbon, okay, and here R group and OH. So you will get this product. And what is this? This alkyl group is from the Grignard reagent. This alkyl group has been attached. Now let's understand the mechanism first, because understanding the mechanism will clear you all your doubts. So this is your carbon compound. Okay, first step में you are just treating it with RMgX. Now you know very well when metal is attached to the alkyl group. So between this magnesium and alkyl group, which one will get positive charge? Yes, Aisha. Which one will get positive charge, बच्चे?
R.
Why R? ये तो common होता है. When we use commonly, the R alkyl group will get the positive charge. But when it is attached to the metal, magnesium metal in the Grignard reagent, हम कब से पढ़ते आ रहे हैं haloalkanes, haloarenes topic से. Again and again, I'm just repeating this topic. When metal MgX, this Mg is attached to the R group, alkyl group. So always remember this magnesium is electropositive. Metals are electropositive. So this will acquire partial positive charge and this alkyl group in this case will get the negative charge. Okay, just remember this thing. Commonly the alkyl group will get the positive charge. But here, just opposite hota hai in the Grignard reagent. The metal is attached to the alkyl group. So metal will get the positive charge and the other group will get the partial negative charge. Right? This will get partial negative charge and this will get partial positive charge. And between this carbon and oxygen, this is partial positive. Right? Because oxygen care, this is more electronegative. So it will acquire partial negative charge. So the other atom will get the partial positive charge. Now it becomes more simple when you recognize the sign. Now see, this is negative charge, so it will attract this one. ये इस पे attack करेगा, right? This R group will attack this carbon. Now, what happens? Okay, try to write down the mechanism along with me. So when this R group will attach this carbon, so this bond will shift over here, right? So here R group, here other alkyl group, and here O minus. Okay, O minus. So this MgX has a negative positive charge, so it will get attached to this O minus Mg, which is having a positive charge. Now further, when you add water to it, okay, when you're doing the hydration, so what happens? So it will give you H plus and OH minus sign, right? So H plus get attached to the oxygen, which has a negative charge, and this Mg X के साथ क्या attached हो जाएगा OH. So you will get COH. Okay, here other bonds, and plus you will get MgOH. So that is the proper mechanism. That is the proper mechanism. Is it clear?
Yes, ma'am.
You can see this is the product. This is the product. Carbon. And again, the same thing will happen. The OH group and the alkyl group of the Grignard reagent will get attached to the same carbon. Okay, same carbon पे आपने attachment करनी this thing. Okay, so if it is clear, then let's do the other questions. Suppose we have HCHO. We are treating formaldehyde when you treat it with RMGX. And in the second step, you are doing the hydration. Now write down the final product. Second, R dash CHO. Again, the same reagent. Third, R dash CO, R dash dash. Suppose this is a ketone. Okay, I think we have discussed this. When you treat a formaldehyde with the Grignard reagent, you will get a primary alcohol. We have discussed that, right? When other alcohols, when it is on treatment with the Grignard reagent, it will give you a secondary alcohol. When ketone treated with the Grignard reagent, it will give you a tertiary alcohol. We have already discussed that. Okay, just quickly write down the product. I will ask you. Done?
Yes, ma'am.
First one.
Carbon with hydrogens on both the sides.
Tell me the final product. You can write RCH2OH, right? What is this? RCH2OH. So basically, you will get a primary alcohol. In the second case, when it is R dash CHO, so let's see the mechanism first. R dash CHO. If we are treating with RMGX, so it will have the partial negative charge, positive charge. It will have here R dash CH and here R and here O minus MGX. Further hydrolysis. Okay, R dash COH H, right? And here R. So what you get, you are just getting this is R CH R dash and OH. You are just see this. This is a secondary alcohol. OH is attached to this carbon, and it is further attached to two different alkyl. Okay, so here in this case, you are just getting the secondary alcohol R CH R dash OH. Okay, plus MgOH. It's no need to write that in the byproduct. So you are just getting the secondary alcohol. And the third one, this is your ketone. So ketone on the treatment with the Grignard reagent, the product will be your tertiary alcohol. Right? It will be R dash carbon R group. This R group is from the Grignard reagent, and this the R group R dash double dash, right? R1 and R2 you can see. So you will get tertiary alcohol. So just remember, formaldehyde on treatment with RMGX, take Grignard reagent, so you will get a primary alcohol. In the second case, other alcohol के other aldehyde के साथ आप treat करोगे other than formaldehyde, so you will get a secondary alcohol, and the ketone on the treatment with the Grignard reagent will give you a tertiary alcohol. Yeah. Next topic is reactivity of aldehydes versus ketone towards nucleophilic addition reaction. Reactivity of aldehyde versus ketone towards nucleophilic addition reaction. So first, let's understand about the aldehyde. And here I'm just writing the for the ketone, aldehydes and ketones. So aldehyde is RCHO group. This is your aldehyde. And what is ketone? When both the sides alkyl group is present. Now see this, Jovita. This is aldehyde. Now, between this carbonyl compound, this carbon has a positive charge. Between this carbon and oxygen bond, this oxygen is more electronegative, so this will acquire partial negative charge, and this carbon will get partial positive charge. So here, only one alkyl group is present. In the aldehyde, only one alkyl group present. So there will be less plus I effect, less number of plus I effect, because you know very well this alkyl group is a plus I group. Okay, this is an electron donating group which pushes the electron density towards the adjacent carbon. So what happens when there is only one alkyl group? So there will be less inductive effect. Okay, so this R group kya hai? This is a plus I group. So here it will show the plus I effect. Okay, so plus I effect is due to the electron donating group. So this alkyl group, it pushes the electron density towards this carbonyl compound. Okay, now you can see here in this ketone, there are two alkyl groups. So there will be more inductive effect. There will be more inductive effect. This alkyl group will push the electron density towards this carbon, and this will shift towards this carbon. Okay, so this carbon will get a negatively because electron density is ki taraf hoye, so there will be more electron density electrons to this carbon, right? Now, what happens? Because if you add the nucleophile, because nucleophile is electron rich, it is a electron rich, right? So it will attack that carbon which is electron deficient. Which is electron deficient, जो electropositive होगा, right? If there is more alkyl group, okay, more alkyl group, so there will be more inductive effect, plus I effect, okay, and due to the more plus I effect, the electron density on this carbon will be more. And if electron density with the, you can see this ketone, this has more inductive group, okay, plus I group, so there will be more electron density on this carbon. So it is again electron rich, and this nucleophile is again rich. Okay, so between this aldehyde and ketone, which one is more reactive towards the nucleophilic addition reaction? This aldehyde. This aldehyde will be more reactive towards the nucleophilic addition reaction. Why? Because there is a less number of plus I group, which makes the carbonyl compound more electron poor, okay, or electrophilic, you can say. Okay, more electrophilic. And this nucleophile will get attached to that carbon which is electron poor, which has deficiency of electron. Is this point clear to you all?
Yes, ma'am.
Okay. Now you can write point by point wise. First point, write down. So here in the aldehyde, less number of plus I group is present. Plus I group is there. So it makes carbonyl carbon more electron poor. Okay, and in this ketone, more number of plus I group makes carbonyl carbon less electrophilic. Less electrophilic. Right. And this steric hindrance. Steric.
Ma'am,
Yes, Jobita.
more number of plus I group, I
Yes.
group only.
More number of plus I group. Yes, Jobita. Complete your question.
No, ma'am, I had a doubt. I thought it was like negative I group. So
No, plus I group. Negative inductive effect minus I effect is due to the electron withdrawing group. Just like your halogens nitro group, but this is plus I effect. Plus I effect is due to the electron donating group. Just like your alkyl group, right? Alkyl group will just push the electron density towards it adjacent carbon. And due to the, this, see this, in the ketone, this alkyl group and this alkyl group. From both the sides, there will be a push, right? So this alkyl group, this is plus I group, so it will push the electron density towards this carbon. And again, this alkyl group will push the electron density towards the carbon. So the electron density on this carbonyl carbon will increase. Okay, so this carbon will have the, it is less electrophilic. Okay, less electrophilic and less electron deficient. It is electron deficient, but less electron deficient, okay, as compared to this one. So this nucleophile will attack this aldehyde. The reactivity, the rate of reaction will be fast in the aldehyde as compared to the ketone, right? Because the nucleophile is again a electron rich. और ये किस पे अटैक करेगा? Where the electron efficiency is there, right? So the where the electro deficient center is found. So that's why in aldehyde the reactivity is higher. Okay, because due to the presence of this alkyl group, there will be a less steric hindrance, right? The steric hindrance will be low due to only one alkyl group. But here you can see two alkyl group. Due to the two alkyl group, the steric hindrance is high. Okay, so that's why the reactivity is lower. The nucleophilic addition reaction reactivity is lower in ketone as compared to the aldehyde. Now it's clear?
yes, ma'am.
The steric hindrance, write down, is low. Why? Due to one alkyl group. So here, so therefore, reactivity is higher. And on the other hand, the steric hindrance is high due to two alkyl groups. Alkyl groups. Therefore, reactivity is lower. So here, the rate of nucleophilic addition reaction is inversely proportional to the bulky group on carbon double bond oxidation, right? Carbonyl. So whenever more bulky group is present on the carbonyl carbon, right? So the rate of nucleophilic addition will be less. Okay, so it has a rate of nucleophilic addition reaction has an inverse relationship with the bulky group. More the bulky group, okay, less will be the rate of reaction, and vice versa. Is it clear?
Yes, ma'am.
Next, fifth one is the reaction with alcohols. Reaction with alcohols. Okay. Now suppose we have a R aldehyde, RCHO group. Okay, and you are just treating it with alcohol R-OH in the presence of a dry HCl. Okay. So first, let's write on the definition. When aldehydes react with monohydric. Just remember this. When aldehydes react with monohydric alcohol, only one OH group should be present, right? Monohydric means only one OH group should be present. Monohydric alcohol in the presence of dry HCl, dry to form alkoxy alcohol. What happens when aldehydes reacts with monohydric alcohol in the presence of dry HCl? So it first forms alkoxy alcohol. Okay, and what is alkoxy group? You know very well. This OR group should be attached. OR group should be attached to the carbon, alpha carbon, right? So that is your alkoxy group. What is alkoxy group? This O. And the alkyl group is attached to the oxygen. So this is your alkoxy group, right? So it will form alkoxy alcohol. And alkoxy alcohol को हम क्या कहते हैं? Hemiacetal. What is this? Hemiacetal, which reacts this hemiacetal when reacts with one more alcohol, and it forms acetal, and it forms basically gem dialkoxy compound. Gem dialkoxy compound. So this is known as acetal. Now, why we use gem word? So there are two words, gem and vicinal. Vicinal. So vicinal word is used for that group in which, for example, vicinal diol. If I say vicinal diol, so this carbon and carbon, right? So adjacent carbon pe if OH group is present. Why we use vicinal? The vicinal word is used for that compound in which the functional group, the same functional group is attached to the adjacent carbon, the neighboring carbons. So that is a vicinal type of compound. Now, what is gem? So gem word is used for that group So the functional group should be attached to the same carbon. Okay, same carbon पे OH and OH group is attached. So this is your gem diol, gem diol. Okay, and this is null for the neighboring carbons. And neighboring carbons पे same function group is attached. Is it clear?
Yes, ma'am.
So what is this reaction? So when you treat the aldehyde, suppose aldehyde लिया हमने, first you will just treat it with the monohydric alcohol. So in the presence of dry HCl, so it will form R. You will write RCH as it is, CH as it is, and this oxygen, it will reduce to this OH group, and this OH will not get attached. This alkoxy group, just remove this hydrogen and this group. This OR dash group, this alkoxy group should be attached to this carbon. This whole group will get attached to this carbon. Now say what happens, this hydrogen, now the bond will get cleaved from here. OH bond will be cleaved, and this hydrogen, this will get R dash O, okay, R dash O minus, and it will get H plus. It will dissociate it like this. R dash O minus and H plus. And you know very well this is electropositive, right? This carbon is electropositive. So this R dash O, this is R dash O minus, this group will get attached to this carbon, which is electropositive. Yes, Jyotita.
Ma'am, I have another class right now. Can I leave then?
Yeah, okay, Vaishnavi. Okay, let's understand money bond. And now what happens in this? So this R dash OH, now the bond will not cleave from here. So the bond will cleave from here. This OH bond will cleave, and it will dissociate to form R dash O minus and H plus. Now between this carbonyl compound, this is electropositive, right? So this minus charge, this negative part of this group will get attached to this carbon, and here the negative will shift here. So what happens? First, what happens? This group get attached R dash O. So you will write, and from the oxygen side, you will show the attachment. And this oxygen will get negative charge. This bond will shift over here. When it get negative charge, this hydrogen will came, H plus ion will came and get attached over here, and it will form OH hydroxyl group. OH. So that's how it forms a hemiacetal. So hemiacetal group is that group in which this OR dash, okay, alkoxy group is attached to this alcohol. What is this? This whole thing is an alcohol, right? And this OR dash again should be attached to this carbon. So this is your alkoxy group, and this is known as hemiacetal. Hemiacetal. So hemiacetal किसे कहते हैं? Alkoxy alcohol. Alkoxy alcohol is the hemiacetal. And if you treat this hemiacetal with the another alcohol, one more alcohol, so what happens? इस OH की जगह पे भी एक OR dash group आ जाएगा, and you will get a gem dialkoxy alcohol, not alcohol, compound you can say. In that case, you will not get the alcohol. OH group नहीं होगा उसमें. This OH group should be replaced by the OR dash group, alkoxy group. So this will form acetal. Now see. So this is your OR dash group, and this OH group should be attached to this carbon. So this is alpha carbon, right? Now what happens next when you treat this group, this compound with another alcohol, R dash OH. Okay, no, don't take this R dash. Suppose this is your R dash, so we will take R dash dash, right? R, suppose this is R1, so this is R. Now, what happens next? Again, the same thing will happen. This OH, you have to remove this OH group and just attach RCH, and this will be as it is, OR dash. And here you will write OR dash. Right, so this will form, and what is this? This is your acid. This is your acetal. You can see to the same carbon, the alkoxy group is attached, right? So what is this? Gem dialkoxy compound, which is also known as acetal. Okay, so that is the reaction, and this is important reaction. Reaction with alcohol. Reaction of carbonyl compound with the alcohol. Clear, Muniba?
Yes,
The
ma'am.
reaction and the mechanism.
Yes, ma'am.
Okay, next. Similar reaction will be done for the ketone also. Next point, write down. Suppose we have R, again this is aldehyde, plus, okay, if you don't have to write down the whole mechanism, you only have to write down the product. Suppose we have ethylene glycol. What is ethylene glycol? Do you know the structure? What is the formula for ethylene glycol? Yes, Muniba. Ethylene glycol. Glycol we use for the 1,2-diol, vicinal diol. Okay, and it is ethylene. So CH2, CH2, and to the both carbon OH is attached. So what is this? This structure is known as ethylene glycol. Okay. So when you treat the carbonyl compound, basically it is aldehyde with the ethylene glycol in the presence of dry HCl. So what happens from here? This hydrogen, and this oxygen. Yeah. So this will combine and the water will be released. And how to write on the product? Let's see. This is R. Okay. This is carbon. This is hydrogen. And you have to show the attachment. What is the remaining group? O, CH2, CH2O. This is your ethylene glycol. So from the ethylene glycol, only 2 hydrogen has been removed, right? So you have to show like this. This double bond, carbon should be attached to this oxygen. आपको इससे attachment कराना है. And the other group as it is, you will write CH2, then your CH2, then this oxygen, and again. So basically, it will give you a cyclic type of a structure. And what is this? This is your cyclic acetal. Cyclic acetal. So when you treat the aldehyde, okay, when you treat the aldehyde with the ethylene glycol in the presence of dry HCl, so you will get a cyclic acid. Clear, Maniba?
Yes, ma'am.
Aldehyde reacts with dihydric alcohol. This is for the when it aldehyde react with the monohydric, so it will give you a acetal. Okay, the aliphatic type of acetal. But when the aldehyde reacts with a dihydric type of alcohol, right? So it will form a cyclic acetal. Dihydric alcohol, so it will form cyclic acetal. Just remember that. When the aldehyde react with the dihydric, so it will form cyclic acetal. And for the monohydric, it will just normal acetal. Similar example, you can take it for the acetone or ketone. Suppose this is R, C, R dash, oxygen. Again, we are just treating it this ketone with the ethylene glycol. Same procedure will be there. Okay, this is ethylene glycol. What you're supposed to do, 2 hydrogen and this 1 oxygen. They will be removed, and here in the presence of dry HCl. Water remove हो जाएगा, and how you will write on the product R dash, and you have to show the attachment. This carbon and this oxygen will get attached, and it will form a cyclic type of structure, which is known as, what is this? Now the name will change. The cyclic acetal has been derived from the aldehyde. So that's why it has been named as a cyclic acetal, right? Now, but this is in the ketone, it is derived from the ketone, so it will be named as a cyclic ketal. What we call it as a cyclic ketal. Okay, just remember that. When the carbon here is R and R dash. Okay, and this group is same, OCH2, CH2O. This is same. Only the difference is here. Carbon should be attached to 2 alkyl groups. So that is a cyclic ketal. And what about this one? This is a cyclic acetal because here the hydrogens. So this has been derived from the aldehyde. So that's why it is cyclic acetal, and it has been derived from the ketone. So that's why it has been named as ketal. Clear, Maniba? So
Yes, ma'am.
in the notes you can write down acetals, acetals and ketals can be hydrolyzed with aqueous mineral acid. Mineral acid is just other than your organic acid to form parent aldehyde or ketone. Okay, so note me, write down acetals and ketals can be hydrolyzed. Okay, hydrolyzed with aqueous mineral acid. Do you know what is mineral acid?
No, ma'am.
Other than mineral acid is an inorganic acid. Other than organic acid which contains like ethanoic acid, carboxylic acid, just like that. Organic acid, formic acid. So organic acid are weak acid. But mineral acids जो होते हैं, they are strong acid. Inorganic acid, just like your HCl, nitric acid, sulfuric acid, phosphoric acid, boric acid, etc. So these are mineral acid. These are known as mineral acid. Okay, and these are a strong acid. So in the presence of a strong mineral acid, aqueous acid, basically dilute up HCl, dilute H2SO4, just like that. So it will form this ketals and acetal. They again transform or can be converted to a parent aldehyde. Just say वो derive हुए थे. So suppose this is a cyclic ketal. If we have to reverse this reaction, so we have to treat it with the aqueous mineral acid. Okay, so we have to hydrolyze the cyclic ketal with a aqueous mineral acid to form its parent carbon. So parent aldehyde or parent ketone. Okay, so what happens? Suppose we have this group CH3, CH, and OCH3 and OCH3. So what is this? This is your acetal, right? What is this? This is your acetal. OCH3 group, OR, and OR group is attached to the same carbon. So what is this? Acetal group. And when you add H plus, okay, dilute form of acid, okay, आप dilute HCl, right? So dilute HCl will dissociate to form H plus ion in the presence of water. So you are basically hydrolyzed up in the presence of an aqueous acid, aqueous mineral acid. So what happens? This will get converted. This whole group OCH3 group, ये दोनों group क्या होंगे? This will be removed and you will get a CH. Okay, this will get a CH and here you will attach oxidation. So whole thing, this alkoxy group, methoxy group, and both the methoxy group will be removed and just add the O group. Okay, आप इसे carbonyl बना दोगे and H is already there. Okay, already there to this carbon. We will get the parent aldehyde. Suppose we have another example. This is OC2H5. So this is OC2H5. This is your ethoxy group. So again, when you do the acid hydration, क्या होगा? This whole group you will remove. When you remove the whole group, what you're supposed to do? This carbon. जहां से आपने remove करा है, तो that carbon पे you will attach the oxidation. What is this? In the second example, we are just getting the ketone. But in the first one, we are just getting the aldehyde. Similarly, for example, we just take the cyclic ketal. Suppose this is a cyclic ketal. And इसका आप hydrolyze करा दो. in the presence of dilute HCl. So what you're supposed to do, this whole thing, just remove that. Okay, just remove the whole thing and attach oxygen, double bond oxygen to this carbon. So you will get this one. You will again get the acetone. Clear, Maniba?
Yes, ma'am.
Okay. Okay, so that's all for today. I think on this platform there is another class. So we have left with main reactions has been left. Reduction of aldehyde and ketone, Clemmenson reduction, Wolff-Kishner, electrophilic aromatic substitution, etc. Aldol condensation in this chapter. Aldol condensation is very important, and there are some tests like Fehling test, Tollens test, which is also known as silver mirror test, iodoform test. So this chapter is again very important. Okay, so if possible, just tell the team when we can schedule your extra class so that we can complete this chapter. Like 1 to 2 more class I need to complete this. Okay, Maniba.
Yes, ma'am.
And if you don't get the time, just please revise all the topics. This chapter is very important. Aldol condensation is very important. Cross aldol, all the test, your silver mirror test, etc. This chapter, अगर आपको time ना मिले, तो just do it by yourself. And if there is any doubt, just ask for the extra class. I'm always there for you. Okay.
All right, ma'am. Yes, ma'am.
Okay. Okay, but
Also,
Saturday. Yes, Saturday I'm not available. On Saturday I'm not available because मेरे भाई की शादी है. Okay.
congratulations, ma'am.
Yeah. So tomorrow, Friday or Sunday, I'm available. I can take your class.
All right.
Any other doubt, Muniba?
Ma'am, could you please share the notes for both the chapters, completed notes and important questions as well?
Okay. I will share I'm going to share the whole notes of this chapter. If you don't get the time, just revise the note at least. Okay.
All right.